In this video, we're gonna talk about the chain rule. So the chain rule is used whenever we have composition of two functions, let's say f rho u of x. Then we can write this as f of u of x. So anything in this form, we need to use chain rule to do it. So let's say in general, they're asking you find df over dx. So find the derivative of f. It's not df over dx, but we write it in this way. So df over dx is the derivative of the function f with respect to x. I can note that f is not related directly to x, it's related to u, and then u is related to x. That's why we use something called chain rule. To do this one, I will write df, but since f is related to u, we write df over du. So the first step is to derive the main function with respect to u, and then the other part will be du over dx. So derive u with respect to x. This is the proper definition of chain rule. However, there is a much easier way to understand this. Before that, I want to remind you with some rules. We know that if y equals x exponent n, or even if we have a number here, so a is just a constant number, its derivative is n multiplied by a x exponent n minus 1. The other rule is, as I said before, it's better to memorize this. I proved it in the other video. So the derivative of radical x is 1 over 2 radical x. And if we have 1 over x, its derivative is minus 1 over x squared. Now, exactly same rules. But for chain rule, I will not have only x under the exponent. I will not have only x under the radical. I will not only have x in the denominator. So whenever you have something of the form y equals a parenthesis, and there is something here in terms of x, so it's not only x, it's maybe x plus 2, maybe x plus 5, maybe x squared plus 2, maybe 2x cubed, whatever. To find its derivative, you apply exactly the same thing you know from before. So you bring the n down, you multiply it by the a, and you will write whatever you have inside the parenthesis as it is, exponent n minus 1. So I'm just applying the same rule, but the only difference here is we need to multiply by u prime of x, by the derivative of what we have inside the parentheses. We're gonna do some examples and hopefully you will understand these very well. The second one, if we have radical of, instead of x we have u of x, then its derivative will be exactly same as the previous one. But instead of x here we have u of x. But whenever we have u of x, I should multiply by u prime of x, the derivative of what is inside the radical. If you want to rewrite this, you can write it as u prime x over 2 radical u x. So I multiplied the 1 by the u prime. The last one, if we have 1 over, instead of x, maybe x plus 2 in the denominator, maybe 3x plus 1, maybe x squared plus 5, whatever. I'll call it u of x. So its derivative will be exactly same thing. So minus 1 over, instead of x here we have u of x squared. But I should multiply, as I said, whenever we have u of x, we should multiply by the derivative of u of x, the one here. So when I multiply, I will get the final answer to be minus 1 times u prime of x will be u prime of x in the numerator over u of x squared. Okay, so if you memorize these rules, trust me, you will solve all the questions in a correct way. Let's do some examples. Number 1. Let's say we have y equals 252 over x exponent 4. Now, or let me make it like this: 2x squared plus 3x. If you want to think about this question, the best way to do it is to write 252 alone multiplied by 1 over 2x squared plus 3x. So I'm doing the question similar to the last one we did there, the 1 over u of x. Now, in this case, u of x is what we have in the denominator. So I wrote it in the form 1 over u of x. Once I write it in this way, I know my answer will be the 252. I don't care about it. Whenever you have a constant number multiplied by a function of x and you're doing derivative, the number stays the same. The 1 over u, look at the rule, it becomes minus u prime over u squared. So this is our u of x. What is u prime in this case? So the minus, I should write it, fraction. U prime, it's the derivative of 2x squared plus 3x, which is 4x plus 3, over 2x squared plus 3x all squared. So the u squared is 2x squared plus 3x exponent 2. Now, if you want to simplify more, here you're multiplying the whole thing by 252. So you can distribute the 252 over the numerator. So 252 times negative sign is minus 252, multiplied by the 4x. So you can write this, and then simplify more if you want by distributing. This minus is for the whole fraction, it's not for the 4. That's why I wrote minus 252 and I multiplied with the whole numerator. Do I need to expand this? No need. Just keep it the same, because in some cases you can simplify a factor in the numerator with a factor in the denominator. So this is my final answer. Only you can distribute for the numerator. 2. Let's say I have to find the derivative of something like this: x squared plus 5x exponent 4. So whenever you have parentheses with an exponent, what is inside the parentheses we call it u, and I start deriving. As usual, we take the exponent outside the parentheses, so we bring it down, it becomes 4. Then x squared plus 5x stays the same. We need to do 4 minus 1, which is 3. But I should remember that this is the rule I'm doing. It's this one. So bring the exponent down, ux exponent n minus 1. So I did 4 minus 1, which is 3. But I should not forget the u prime. So if u of x is x squared plus 5x, the derivative of what is inside the parentheses will be 2x plus 5. Now you're done. Just if you want to simplify more, usually we write the exponent or the term with the exponent, we write it the last one, so x squared plus 5x, and I still have 4 at the beginning multiplied by 2x plus 5. If you want to distribute here, you are allowed to do it. However, the 4 cannot be distributed over this because we have an exponent there. So just don't do this mistake. Alright, so if I want to do it, it becomes 8x plus 20 multiplied by this. And this is your final answer. They will never ask you to expand. So that's it. 3. Let's say we have a question with radical. So I have 24 radical x exponent 4 minus 13. So to solve this question, the 24 is just a number multiplied by a radical of u of x. So I'm doing the second one now. So we're doing something similar to this. Okay. So I have a number multiplied by a radical of u of x. For this question, it can be done in two ways. If you know the rule for radical, then you can do it like really quick. The derivative in this case will be the 24, because it's just a number multiplied, it stays the same. And the radical of u of x, the u is what is inside. This is the u. I will write u prime over 2 radical u. So this is the rule, the one in red. U prime of x over 2 radical u of x. The u of x in this case is x exponent 4. So 2 radical u, I will write 2 radical x exponent 4 minus 13. And on top, I need to do the derivative of what is inside the radical. So it becomes 4x cubed. That's it. So you can simplify if you want. This becomes 1 and this becomes 2. Your final answer will be 24 times 2, 48x cubed over radical x exponent 4 minus 13. Usually they don't ask you to rationalize, so this will be your final answer. But in case they ask you to rationalize, remove the radical from the denominator, you should know the following. Whenever I have square root, so it's just radical, no index here. The index is a hidden 2. Yeah, we don't write it. So whenever you have something like this, you should multiply the radical by itself, up and down. So what you will get is the following: 48x cubed radical x exponent 4 minus 13 over radical multiplied by itself. It will be radical exponent 2. So I will write it in details, even though no need to write this step. The square and the radical, I'm 100% sure that they will cancel out, and we get 48x cubed. In the numerator, we're not allowed to multiply anything inside the radical with anything outside over this. Now, please don't do the following mistake, which is, many students, they tend to do the following: x cubed and x exponent 4, we simplify 1, 1, it doesn't work. Why? Because in the numerator we have multiplication. However, I have subtraction here or addition. We cannot simplify anything. So this is your final answer. Done. That's it. Alright. Now, if you want to solve it in a different way, some students, they tend to do this. So instead of radical, they know it's exponent half. Why is that? Because radical of x exponent 4 minus 13, this idea will help you. So radical of x exponent 4 minus 13, it doesn't have an exponent inside, so it's just 1. And this is radical, it means it's a square root. The 2, we don't write it, it's hidden. So this radical, it changes to exponent 1 divided by 2. The one inside divided by the one outside. So we write x exponent 4 minus 13. Now, to proceed from here, we can do the first rule we have here. So a multiplied by u of x exponent n. So we have like not x inside the parentheses, we have something in terms of x, which is in this case x exponent 4 minus 13. So the half should be brought down. So we get 24 multiplied by half, x exponent 4 minus 13 exponent 1 over 2 minus 1. But we don't forget to multiply by u prime. So this is the u. I need to multiply by u prime. U prime in this case is 4x cubed. We finalize our answer. We need to simplify it. So 24 divided by 2, or 24 times half, is just 12. And this becomes x exponent 4 minus 13 exponent minus half. But usually we don't keep negative exponents, so I need to do something about it. To make the exponent positive here, we need to bring it to the denominator. So it becomes 12 multiplied by 4x cubed. The 12 is not related to the exponent negative half, and this one is not related to it. So what is inside the parentheses with exponent negative half will go down. It becomes x exponent 4 minus 13 exponent half. To continue from here, we get 48x cubed over the exponent half. We know it's radical. We go back to the radical form and we get the same answer. If you need to rationalize, so look, it's the same answer. If you want to rationalize, you can multiply the radical up and down as we did before.